Welcome to this episode of the... What do we call it again?
I don't know. We were trying to decide a name before new. It's actually been a long time. There's a couple of small reasons that I guess we could talk about there. I completely forgot how long it's been since we did one of these. But yes, the name's up in the air. That was the latest news.
I know the name of the people that are here. This is Richard Park, my colleague.
Yes, that's
Adam
me.
Botsevsky.
Yeah.
Hi.
And this is a show where we talk about APL and notation as a tool of thought.
Yeah.
And that's what the show podcast, except we also release videos. So now it's just a show. That's what the show's about.
Wikipedia says that a podcast can be video as well.
Well, that makes sense because there's a good number of podcasts that have both. They're on YouTube and they're on. But yeah, it's called APL Notation as a Tool of Thought, which, while fairly descriptive and definitely unique and probably easier to Google than some array language names, is a little bit clumsy, I guess. I don't know. I kind of like the jank, but I can understand for like being able to remember marketing purposes why people might not think is the best name. So fine. So we decided we did. I think Adam, you just basically did this on your Twitter.
Yeah.
A couple of straw polls, a couple of polls.
Yep.
Did two polls? Why I forgot?
We did two polls because then there was another suggestion. We had to add that.
And every time you get a suggestion, you got to do another poll.
Start over.
So what was the top? What was the top? Are you able to share the?
Yeah, I can share that.
The results. Because I don't even know how many people replied. It can't have been that many.
Yeah, sure. Let's do this. So let's see the original one. You can find that.
That's the original one. Yeah, we had suggestions as well.
Well, that was the original one. Eliminated keeping the name, just APL notation as a tool of thought, and then we instead of that we added in the new suggestion, which was what was the new one? Glyphcast? Or was that just APL cast? There was Connor Extra said there should be APL cast. And then that won by a large majority. It's got absolute majority. However, podcast, when people usually associate that with video, you're right, and we can't get a good domain name for that.
Essentially, where we've come to with this, is we were looking for a domain to do like APL cast. We could do aplcast.org or whatever, yeah. but then we found.
But yeah, so the idea is that since we did this poll on Twitter anyway, we're going to follow the trends of former richest man in the world, now Chief Twit. Elon Musk, of making such polls and finding out what the world wants and then doing whatever we want instead.
It's actually a bad idea, but let's
you just roll with that here.
We should call it APL cast. But
we'll call it the APL Show.
Yeah.
And the URL for our site, when we get that up and running, will be just apl.show.
Yeah.
Which is pretty cool.
Yeah.
So now that's out of the way. Thank you for voting. Sorry, we didn't care about what you voted for. No, we did care. We very much cared. We just didn't follow it. That's all.
Yeah.
So
I'm still not even sure that's the best idea, but it's funnier to roll with it, and we don't get to keep the other name, which I think is more fun.
Well, we still call it APL Show Notation as a tool of thought, right?
Yeah. We've got the tagline and. Yeah, let's talk about notations in the context of thinking and other stuff. So I think the last episode, like I said, it was a long time ago. There was the Christmas period. I got pretty ill, and then Adam had some really good news in the new year, which has been taking up a lot of his time.
I had a baby. That's what.
Yes, yeah. So. I'm using that as an excuse, even though it's not really the only. It's not really the reason we haven't done one in so long, but it's nice. So congratulations, Adam.
Thank you.
I think you might have been. Every podcast you're on, this is getting mentioned.
All two of them, yes.
But in the previous one we were talking about functional forms, and then we'd sort of talked about that in the context of like early versions of Iverson Notation / APL, especially the one that's quite easy to find and relatively famous is the APL 360 CPU description, right? Because it's it's got things that still are in APL.
Hold on. You're talking about the IBM 360.
The IBM 360, that's right, sorry. It had APL 360 on it, and that was called APL 360 because it was on...
So the chronology is Iverson worked at IBM. Iverson had developed his special mathematical notation that didn't really have a name. Iverson Notation is what we call it today. And it was then used to describe the IBM 360 and to help with the design of the IBM 360 system that IBM was betting everything on, that it would take over computing, which it did. And every computer system today is in principle a descendant of the IBM 360, and all other competing technologies just went out the door. That's it.
In what sense is that? What's the
well, the whole architecture,
the distinct architecture that makes
here's just one thing. It was the IBM 360 that introduced the 8-bit byte.
Well, okay. Did not know that.
That was revolutionary. It changed everything.
To be fair, yeah, it is arbitrary, isn't it? Like,
there were systems before that used other.
Yeah, if you ever done like hobbyist electronics, you get those memory chips, and they've got like, some address space, and in principle, you're using that many bits. It's not. I guess you still call a byte 8 bits because that's the convention that clearly comes from this. But I mean,
they're called octets in French, I think.
All right. But yeah, you can have a 4 bits is a nibble, isn't it? And then I guess 2 bits is just like.
Anyway, but the architecture of having the disk space and working memory and 32 bits and all the stuff that.
I guess it's so universal. You don't even think.
We don't think about.
That's what I'm really curious about. Is like, what's the alternative?
You could do anything. I think there were Soviet computers that used base 3 rather than base 2 in the electronics, right? The electronics themselves are running at 2 different voltage levels with usually like 5 volts difference in between them for zeros and ones. Everybody knows the computers just do zeros and ones, but in reality they do zeros and 5s, or probably more like 1s and 6 or something like that.
But it's obviously having with like diodes and other little binary switches.
You can do ternary. And there were decimal computers where everything was stored in decimal in the lowest level rather than in binary.
So like a voltage between 0 and
no, but you could store it in binary, but you're storing decimal digits.
Huh?
You can encode every decimal digit in binary or in ternary or whatever you want to do.
Yeah.
But all the computations are done on them in using decimal math, not binary math.
But I guess
we just take out
probably just simpler and cheaper in the end, is it?
Yeah, and you get weird floating point errors.
No, I mean to have yeah, okay. Literally floating
yes.
Because the voltage. Anyway, we're not an electronics
no,
podcast.
That's that other podcast, whatever that's called.
Damn, we should be called APL. I keep referring to ourselves as a podcast. Doesn't matter.
So the IBM 360 was revolutionary, and obviously as APLers, we will attribute all of that success to the fact that it was designed using in Iverson's notation.
Yes, right? Not really anything else.
And then
other features that we're currently talking about. No, it was the original description, the way it was described in the notation, that is the key to its success.
And then it went full Gödel. Incompleteness stuff. A system cannot describe itself by then having people taking Iverson's notation and implementing it on all things machine. The IBM 360 that has been designed with that same thing.
Yes. Except they couldn't quite. Well, I think we talked about this, right? Like the linearization and
they couldn't quite. I don't know if they could have, but it wasn't practical. Once it became more than a description that's intended only for human consumption, right? There never was any system that could execute Iverson notation.
Yeah.
And Iverson notation even contains, well, tacit stuff if you want. It has things you can omit based on context.
Right, okay.
So you don't have to specify the length of something if it's going to be paired up with something else that has a length, because obviously it has to have the length that matches, things like that. And I mean, it's very, in that sense, it inherited from traditional mathematical notation, right? That also relies on the goodwill of the reader to get the correct understanding of certain phrases and notation. So they linearized it, they formalized it, and that was APL. That's APL as we know it. And today's APL are basically just extensions of that, and mostly preserving backwards compatibility, other than very few details. But the original Iverson notation was this very much like flowchart typey thing.
Yeah, so we were talking about the structure of programs rather than the, I guess, expression of algorithms using the notation is maybe what you'd call writing an APL expression or Iverson notation expression. One line, it might have several pieces to it, but it kind of describes one transformation of arguments into a result. But eventually you want to put together a bunch of those, and then the conventional, obviously there's more ideas now, the conventional sort of analogy of that is maybe like a recipe or something else, where you've got like one step and the next step. Now there's, with functional programming ideas becoming more prevalent, I guess there's other stuff. I guess it's still steps, it's just the way you write them is less of this like a flow chart, and more like what's the border between the function composition and just writing those? Because it's like depends how explicit you want to write it.
Yeah, I mean, function composition.
Think about over, for example, whatever. Because you could write that explicitly in like 4 lines, 3. Is it do this one, then do the other one? You've stored those both in.
Well, yeah, you could store both, but you could also just as long as you have
write it lots of ways.
The operand, the pre-processing operand has a name, then yeah. So
the note. So I mean, that's kind of an interesting aspect, right? Because in that case, and especially, I mean, over's a nice one as an example. It's the symbol, but this is a through line of all APL. The symbol subordinates the detail that otherwise you would be writing out in this longer format, right? Which is very useful when you are trying to use that in lots of different contexts, or applying it in different places.
But there is a big difference then between function composition, if you want, which you can build an entire application just from that.
Yeah.
And say a piping that you've got. Some programming languages have this pipe operator thing where you take the result of some one expression, you feed it into another expression. You can either be with some kind of placeholder symbol saying the value from the previous expression goes in here, or it takes the first slot available. You got piping on a command line, operating system command line.
So the only difference is the kind of I guess the notation of how a function name is written. Usually it's like one bit of text with no spaces in it, and the arguments that are passed to them, which obviously one pretty distinguishing factor of APL against other or Algol style ones is not doing the like open paren comma separated list of things. We have this infix thing that is useful, or it's very nice to use when you're like playing with the language.
But the funny thing is that I don't know if most, because it's hard to count programming languages, but the common programming languages will have what they call functions, which are these name, open paren, some arguments, and some languages allow you to omit those parentheses and just write the function name. But they usually also have, other than Lisps and Polish notation, reverse Polish notation, they have infix, what they call operators.
Oh, yes, true.
I think everybody recognizes the notational nicety of the infix notation.
Yeah, I think I was trying to describe, or I was just talking about APL with a friend who's doesn't really know anything about APL, but he's a programmer. And he was like, "Oh, there's too many symbols. Maybe you can have like a few symbols." And I think he meant, I didn't get clarity on it. We weren't really talking about that. I think he meant those operators, the common ones, the plus, the star, and then sometimes you get ampersand, two ampersands, two vertical bars for or. They're sort of, that's become a common nomenclature between these different, even if the languages are quite different in a lot of other ways, they'll have like plus means plus in basically all the programming languages, is like the cross like that.
And minus means minus.
So it's funny, is there really a limit to what people are willing to accept as like introducing a new common set of symbols or whatever? Probably it depends on who you ask, almost definitely. So I don't know about that. I was sort of sorry, yeah. To bring it back to like we'll talk about the notation used. I'm actually going to go off. Unless you got something specific linked to this, I was going to go off and maybe hopefully come back with, we're talking about function, how you express the structure of a program that might consist of multiple expressions. And I sort of had alluded to, I think back in the last episode, the idea of node-based programming. But actually, before talking about that, I was thinking about notations that are used in different domains anyway. Because like you say, the Iverson notation, there wasn't a machine that did that. It's principally always been expressing ideas to other humans. It just happened to be about data processing, which is something that computers do. But ultimately, when you talk about good notations, it's like what is good for a person to use to express their ideas. And now, in the marketplace of ideas, the best one doesn't need to win, right? Or okay, that's a very loaded statement. You might wonder why, if Iverson had this rationalized mathematical notation, like why is that not? And it is better for, or it's definitely nicer for describing certain types of things.
Right, there are two parts of it, right? There's a low level, the actual expression on what you're doing on the data, and then they linearized that. What linearized means, no superscript and subscripts, basically.
Yeah, like how text is written on a screen, it's one character after another. Actually, that's not as true anymore with typesetting.
How it's written on a typewriter, let's say like that. And even there, it's not entirely.
Yeah, even there, it's not really true. I just thought about because LaTeX and stuff. I mean, that's an interesting thing. You can write mathematical expressions in LaTeX, but does anyone have a thing that just executes mathematical expressions written
like that
in LaTeX?
Yeah, there were some graphing calculators you had in high school that where you could enter expressions not in LaTeX, but in some kind of graphical thing with moving up around, and Wolfram Alpha, the public facing thing. They recently added that feature as well. You can enter.
You bet you could easily type it, Wolfram Alpha,
and then translating to. It might not be obvious what you mean if you actually type it in LaTeX, because it's symbol based, not meaning based. So let's say you're using vertical bars. What exactly do you mean by that? It can mean various things. It's just a notation for the symbol, right? You can use a middle dot. You can also use the cross type multiplication sign. It's not always clear exactly what do you mean, or an over bar over a character. So I don't think you can necessarily execute that without deciding what do things mean, and you might also need to decide on some precedence order, because it's not clear as well. You can also make ambiguous stuff in traditional mathematics. But I want to go a little bit saying the one is the linearization of the expressions themselves. But then if we take the step up and you look at the flowchart type things, so decision trees, we could say, so there's a pure decision tree. Like you're looking at some flower, you want to know its name. So you look at all these aspects of it, yes, no, or how many, and then you spread out to each one of those 5 branches. And then you arrive at a name at the end, or a couple of names at the end that it could be.
Yep.
Or for mushrooms, or for solving some problem, or when you call into some help line and you have some mindless person answering the phone. Yeah, exactly. And then
don't ask you a query. They ask you questions. Yes.
Yeah, exactly.
Does it hurt when I poke this?
Yes, or for let's take the UK NHS helpline.
Okay, yeah.
Right, so because you call in, you tell them your problem, and then they start asking you questions, which you have already answered by you explaining what the problem is, but they didn't actually listen. Now they're listening and to the answer to specific questions, and they're going through a chart, which you can also find online, making that helpline on the phone a little bit useless.
Not for people who like phone calls, I guess.
Yes, but the idea here is the importance that we put in these flowcharts, and I'm not sure if it's so obvious the progression. So it's common independently of programming language. So you make some high-level flowchart on how you want your application to work or your system to work. It could be a machine.
Oh, you describe in all kinds of systems. What's the one that comes up a lot that's always in a circle? Krebs cycle in biology.
Oh yeah,
right?
Sure. It's also a flowchart type thing. Yeah, it doesn't.
No one writes that linearized. No one's.
Right, but well,
you could. Yeah,
but
that's a process. So we're talking about processes.
But that's a process that never has branch points.
Well, that doesn't matter that much. Either way, we're talking about the like notation for when people write down processes. They often go to flow charts. But those sorts of diagrams of arrows and blocks and stuff.
I want to point out that there are these 2 orthogonal parts of it. Right? When you talk about the Krebs cycle or other biological cycles like that, there are no branch points. There's only processing. This chemical becomes this chemical.
Yeah.
And then there are non-processing things like the helpline for determining which illness you have or whether you should go see a doctor, where you're not processing any data. There's only branch points.
Right.
Questions all the time. And the combination of that is what programming is. It's the flow with data processing. If you have a program that's entirely just if statements, it's going to be very interesting. Right? It can't really do any work. And if it's completely linear with no decision taken at all, then yeah, it's a processor, but it's hardly even a program. Right? It's just a data processor machine. Now, if you imagine this flowchart, these boxes, and the boxes, then you have compute nodes added to that. So you have these boxes saying, do this, do that, do that, and then and there's sometimes you see flowcharts like that, where there's only one way in and one way out. That's a compute node. That's where you do something.
Yeah.
Now stand up and tap your belly.
Yeah.
Feel a searing pain. Right? Right. So there's actually something there.
If there's one output that's like yes or no to searing pain.
Yeah. Or which level of pain are you experiencing? 0 for no pain, 10 for full pain, and then you have like branch points. Whatever. So the problem with that kind of notation, that would be an ideal way, and then we'll go back. Maybe you want to share your screen on something with the node-based programming.
Yeah.
But if you are typing in the traditional, our computers are really developments of typewriters, right?
Yes.
And they tend to be very linear. Yes, you can like move the paper up and down and make raised and exponents and things, but it's awkward. Normally, you just type if you don't
want to go, you've got 2 axes, you want to go left to, well, in, for English or at least.
You want to go sideways and up, down. That's
sideways and then up, down, yeah.
Yeah, unless you're writing, do Japanese typewriters start by doing a column?
They probably do go, I haven't actually looked this up, but top right down.
And then scroll
back.
And
then one to the left.
I think mechanically there should be no issue with typing that way.
No, exactly.
Anyway,
just
but the problem is if you restrict yourself to that kind of human interface and mechanical interface, then boxes with little shapes and arrows in between them are going to be really, really difficult to type. It's going to be, you can do it, but it's very awkward. So if you look at Iverson Notation, maybe I'll share my screen again. It's an image that we keep showing here over and over again. And we should have other examples than just that one. So this you can look this up under This
is why we keep referring to it, because it's always just
the Iverson Notation page on the AP Wikis. It's easy. It's actually cropped from a bigger page.
Yeah.
But if you then imagine every line in that is a node in a flowchart.
Yeah.
And then you have these little lines coming out various places. The good examples are at the top. And coming in. And then you have lines that don't have any nodes, any connections out and in. So if every line is a node, and the ones that don't have any arrows, sorry, are just the ones that have one way in and one way out. So you take all these different boxes from your page and you stack them on top of each other, and it's not really very important which order you stack them, because you can always just branch around. But you want to do them preferably in an order that mixed for the least amount of branching around, so you just have a linear flow. So then you have it, then you keep going until you have one of those with a little arrow on it, and then that's a decision point.
Yeah.
If the condition holds, then you follow the arrow to another box.
Yes.
It is really just a linearized flowchart, but not linearized in the way the APL became one line. Linearized as in one column of lines of code. And then the next step, so he also has numbered lines.
Yeah.
And the next step is then remove those graphical arrows. Instead, you introduce a little arrow symbol, which he already actually has for when there are many lines and there would be a mess to draw them all. So there's an example here where it says go to, so right arrow, and then a vector, 12, 14, 13, 17, 19, and then subscript, that is indexing, with the N2, which I think is then the second element of N,
which is assigned.
This is why it gets awkward when it's not linearized, because you've got a subscript on a subscript. So you use N2 to decide which line you're going to go to next. Right? And that's really what a traditional APL function looks like. Back in the old days when they didn't have control structures, they would just do these branches. And the little red arrow is really the original big bendy arrow going places, just formalized and linearized to be that.
Yeah.
So you could say an traditional APL function is a flowchart.
Yes.
But goto is considered harmful, some people have said. And there are other ways to structure things.
Well, so it's funny because, there were two sort of things that made me think of this. One I'd like to explore, but again, it's like half an idea in my head, which is a lot of domains have notations that are actually just diagrams. They aren't like a linearized thing. I think I mentioned to you before we started this, but I thought of like chemical formulas, which you can write as like a linearized, H2O, C6, H12O6.
That becomes ambiguous if you linearize it without superscript subscripting.
No, okay, sorry, yeah, but that's close, right? You can write really long ones, but actually, before long, I think you go into 2D diagrams with lines between the describe the bonds, and then I guess you go into those 3D modeling programs as well, even more so.
But if I remember right, there is a linearized notation form for.
For formula, there's one where there's not even superscripts.
Yes.
But anyway, so that was one simple. You can keep looking that up if you find it. You can show that. But so that's one very simple example. Obviously, physics and other things have loads. All kinds of domains have loads of different types of diagrams for describing different things, and some of them are actually used along the steps to solve problems. Some of them less so. They're more like just for descriptions. But then the other thing, and maybe if I find something interesting, we can talk about that another time. But the one that I thought of before, I think I was looking about node-based editors, right? So that's video editing. But it turns out, and as we've seen here, it's not even that new an idea if you think about this as like a sort of flowchart anyway, conceptually. And people have tried it in all kinds of places. So video editors where
that's because you have a
special
is it for a scene or a clip where you say I'm going to do this modification of the image?
It's usually effects. It's usually applying effects. It's also 3D modeling has this as well, where you might have one node that might even be made of nodes within it that describes textures. That's an example that I think I can find, that I can show. Oh, I don't know if I've not got. I think I linked to you. There was a Reddit thread. It was titled node-based programming doesn't scale well, but it wasn't it wasn't really an honest. You can see it in the comments. It wasn't node-based programming doesn't scale well. It's just as possible to spaghettify your whatever you guess you call it code. It is code at the end of the day. It's just as possible to spaghettify your code when you have a node, one of these like blocks with arrows going between them, as it is to spaghettify your code in any other more conventional like language framework, right? If you just keep nesting conditions and branching here, there, and everywhere, the structure of your code becomes nigh on impossible to. That's exactly it, yeah. You can see this looks ridiculous, but if you scroll down, someone's pasted an example where they've done something that's a little bit more sensible looking.
You have to click on the post or something.
Oh yes, you have to click comments on the post. I didn't realize you weren't on it. It says 99 comments. And then I had a quick Google. There's another thing that I found called, what's that called? Nodes.io. That's like written in JavaScript.
Why don't I find it? I remember seeing this somewhere.
Oh
well.
Yeah, it's really not important. The point is, obviously, what you do is you do a certain level of composing different different related sections together, and forming some structure that's more nested, right? So then you're abstracting away some parts of it where if you laid everything out, it would become like, that thing we saw before. Yeah. And just like we saw with, what's quite interesting about what you mentioned in the Iverson example is that he had to do this this sort of workaround for if there was going to be too many lines, it was going to look ridiculous.
Yeah.
And part of both, no matter which version of flow control you end up using, part of the challenge of it, the skill that takes actually quite a lot of time to develop, and people are competent, very competent, excellent programmers still don't really get this like sort of what you call perfect, because you've got to, at the end of the day, you got to get a job done, and that's to design or refine your solution so that you don't have crisscrossing lines everywhere. You don't have insane, ugly, nested conditional statements that are very difficult to follow, very difficult to tell at a glance what is going on, where am I supposed to look when something's gone wrong, and things like this. So, at first it can be appealing to see node-based things and think that looks. I think it's definitely more accessible to certain types of people, people who don't want to write literal lines of code, especially, right? Like that's why the video editing example, and a lot of the VFX programs have this. There's also, scientific domain ones. Simulink, which is from MathWorks, the MATLAB people, is a thing for ostensibly, building simulations, but that uses like a flow chart interface for programming, and another one called LabVIEW, which I think is in a similar domain. So there are lots of these tools. I'll be interested to talk to someone who uses them properly. I suspect it is pretty much what I said, though. Like when you're first doing it, you're sort of you're learning stuff. Sometimes you just got to get a thing done, and you can end up with some really messy, like when you write your first programs, right? You end up with just like this.
No. And when your first programs, then you write them carefully. It's once you get you get old and tired, and you just want to get the work done, you start writing spaghetti code, or you come back to some old system and you need to add some feature or fix an issue, and you add more spaghetti to it.
I mean, this to me feels like the. Well, I mean, software in my mind is still it's pretty Wild West still, with like people making languages and frameworks left, right, and center. There's software engineering practice has kind of come out. There was the thing in the 2000s where it was like OOP everywhere, and now it's like, oh, but functions are kind of cool, and now it's like. And we're like, yeah, but sometimes you just want an expression, don't you? You just want to just like say what you mean. And throughout all of that, the problem of architecting your software at different levels has not really been that solved. I think it's definitely interesting to look at notations that aren't computer interfaces, although
So
obviously
there's
that's
this
where we're
one,
targeting towards.
smiles.
Simplified. So right, the fact that there's, you say this one, you found a page that lists different um, chemical
No,
formula
no,
notations.
no. It's
But
one formula notation.
no. I mean, you said that there's this one, simplified molecular input line entry system.
Yeah.
Presumably that means there are other systems that have been developed or
Oh,
formats
for
for.
molecular input? I don't know.
Yeah.
No, but I think the traditional thing is you write that formula you learned in school with
Yes.
superscripts
Right.
and subscripts and stuff and parentheses. Problem is that's not very
Oh, you
good
couldn't
for
type that on the
computer things.
typewriter.
Whereas
Right.
this you can type you can type these formulas because it's
Yes, I
all just
see.
ASCII strings.
Yeah.
Um,
And
so
look what they've done to make it clear, right? They've put the diagram above it. Because,
well,
well,
yeah.
I mean, I, I'm trying to think. It smells a little bit like on the Arraycast talking about tacit. Are there people who read that linearized thing and are like, boom, that's, I know. I guess you can recognize chemicals if they're not too long.
You'll probably also learn to recognize groups, right? You might, if
True.
you study enough chemistry, you
Chemistry,
soon
yes.
learn to recognize an OH group, right?
Yeah, yes,
And
yeah.
so on. And I suppose as you become more familiar with this, especially if you work with this notation, you start reading entire chunks as that. Like you might as well start asking, are there people who can read different from a partitioned enclosed right tag as one thing?
Well, kind of what I'm saying. Yeah, I guess
Yeah.
yes.
What about
Like,
quote space quote open paren different from partition enclosed right
yeah.
tag close paren x?
Yeah. So when you say it in those words, it does, sounds cumbersome. But when you look at it as a notation,
You
it's
just read
pretty
it as
great.
a whole
Just
thing.
read it. Yeah. You just read partition or split on spaces.
And
Or
human languages are like this as
I don't
well.
even say it in my head, to be honest.
Right, you just read that as a whole thing. Oh, okay,
Yeah.
splitting on spaces and average
Yeah.
and so on, and or inserting something between the first element and the rest of the elements. Something like if you got a one open paren take comma x comma drop close
Mm.
paren y, right? You probably read that as well as just insert something between the first element and the remaining elements.
We should ask Carter about, because I know with like Feynman diagrams, some processes like are problematic in that they just explode into the whole maths. No, the whole process of particle physics is just figuring out which decay paths are so unlikely that you can ignore them. And I wonder if that becomes, well, I guess that's how they simplify it, right? You calculate the probability, you just eliminate a bunch. It's trying to simplify things down, right? Notation to make them manageable for a person, because most concepts, when fully, actually everything, when fully, when fully described, becomes unmanageable because you've just
Yeah,
got too
and
many things.
when you looked at that node-based things, this one
Yeah,
and the one that people were criticizing, although I don't have a higher resolution version of this.
no, it doesn't matter.
Um,
It's a bunch
firstly,
of
it
it's a
isn't
bunch of
actually as bad as you might. At first, you look like, oh wow, that's terrible, but it's pretty legible, especially if you can zoom in on this and see the lines distinct from each other.
Well, no, I mean, to me, you can also see what would be the one obvious way that you might approach this is like it's like a cable tidying problem. You've got a bunch of cables going from one box into another box,
Yeah.
and instead of just letting them just plugging one then the other until you've got this like tangled mess, you'd probably have a think and then deliberately plug in the right ones in the right order to make something that's a bit more legible.
If you can optimize it like that, yeah. But if you look at all these small boxes as one line of code or something, or a couple of lines of code, and then these are all the go-tos in between them, and there might be one main line. So then you take all the main flow through, and you stack up all of those, and then the rest of them you use these go-to arrows. It doesn't
I
seem much harder
I
to
also wonder
follow.
about the limit between because here you in if you're doing a programming environment, well, this is a programming environment that then it's really what you can have is the box, but you click on the box and it brings you a text editor, and then you write the text code that's that thing, and then you abstract it away into this box, and then you're connecting bits of the box together, or whatever. I don't know if that's
that
really
might be
what this
nice.
is.
Like in the APL environment, development environment that we work with, then you can shift enter or double click or on a
That's
name.
right. We abstract it to a name.
Yeah,
that ends up in another.
so then
bunch
you
of
can
lines.
see the name as a kind of pointer that you're going to call that. The difference here is that the flow doesn't progress to something else. You always maintain a call stack going back.
And there is a question which would be interesting to address about. I think we're still working it out, people do it differently in different contexts. Is at what level do you want to abstract, or what level do you want to be able to observe the raw code, right?
I'm sure that in this node-based thing, there's some rectangle around part of the diagram that's not explained. This is way too small for us to even see what's going on. But it's probably possible to take such a box and abstract it away in.
No, it's like grouping.
You can see it's kind of nice. All the connections are coming in from one side, and then there's one connection going to the other. You make that into its own box, and then you can open that up, and then that's kind of similar to that. And then you can also ask, well, at what level should I abstract things away in their own box?
Yeah.
Right? You can write every computer system as a single function with a gazillion lines of and just go-tos everywhere, back and forth, never calling anything else.
Oh, it's just one line of code.
Well, or it's one line of code in the languages that allow that. I'm not sure you can do that in Python though.
No, sorry. I meant after you've put it inside the name, you go, my function is this. This is what happens, right? This is what's kind of interesting about APL in contrast to some is they'll go like, oh, here's 3 lines of Python, but of course it's like 3 lines of function calls that underneath is a whole bunch of stuff. Whereas for sometimes you don't always do this. I want to clarify, but sometimes what you can do is you go, here's 3 lines of APL, and that is the raw.
Yeah, where all the libraries, there aren't any.
Now, of course, you can argue the implementation is a
library, but then every programming language is a library that you're using implicitly.
Well, exactly. How far do you go? And until I'm seeing the bits,
even assembler is way nicer thing, but it builds on having an assembler that can convert it to the binary code. And if you are not old school, then you probably don't want to program directly in bits, flicking little switches on and off.
What does it mean to be raw?
Yeah, my father did this at IBM. You'd use hole punchers, and you punch those bits out. That's what you do, and then you come with a stack.
That's real programming.
Real programmers don't use Notepad. Real programmers use punch cards. Yeah, and then you take the whole stack of punch cards and you put them into the punch card feeder on the computer, and it just munches its way through them. And then things go bad and it can't continue. Then you go and you look at the register.
All I can conclude is people don't want to write programs.
No, you don't want to write like that.
Only crazy people want to write programs. No, anything, any code.
Only crazy people want to stay with the current level of abstraction, right? And you can have too much abstraction and so on, but you do want to subordinate detail. This was one of Iverson's requirements for a good notation, in notation as a tool of thought. Right?
And you want to abstract away up to the point where, because you still need to be able to modify things usefully for your domain, right? You need to be able to change the behavior and plug things together and take the blocks and join them and compose them in different ways in a way that's useful to what you're trying to achieve, right?
It depends.
If you abstract too much, then you have to now take everything apart before you can
unless you're delivering an end product. Right? Some things don't need any more programming. Right? Let's say I recently inherited. Well, my mother didn't die, but I got a robot vacuum cleaner from my mother that she got from my sister.
Oh, cool.
And so it's pretty old by now and doesn't do anything sophisticated. It's not a smart device as far as I know. I wouldn't let those in my
it's just got a simple. Is it like a go left?
Yeah, something like that.
If you can't go left anymore, try going right.
It goes almost in a straight line.
Like a basic maze.
Yeah, I don't know if it's intentional or not that it goes in a slight curve to mix things up a bit. So it goes in this giant curve.
I guess if it was purely scanning, if it was in an inconvenient place, it would be in an inconvenient place for a while.
Well, yeah, so
and that's annoying to walk around.
But it doesn't seem like it's randomized. So it goes in this giant curve, slight curve, and then when it hits a wall, which it detects just by it has like in the front of it has one giant button, like the whole front of the robot.
It literally just bumps in gently.
Yeah, so that thing gets depressed by hitting stuff.
And then we all
everybody gets depressed when they hit a wall, right? So and then it turns slightly to one side.
Yeah.
And then it tries again, and if it immediately bumps, it has some kind of timer or something. If it immediately bumps again, then it makes
the way you're describing it. It sounds like you wish you had a programming interface to this robot vacuum.
We could come up with a better algorithm. So if it immediately bumps into something else, it makes a full 90-degree turn, at least something like that, and then it keeps going again. So there's some kind of timeout. If it hits something twice in a row, then it and it keeps doing this. That's it. That's the whole logic. Go straight, as straight as it goes. Hit something, make a slight turn. If you hit, then keep going again. Or if it hits something and it hits something again, it makes a 90-degree turn and then turns again. And then it keeps like it gets stuck underneath chairs all the time because it hits one leg, then turns a little bit, hits that same leg again, makes a 90-degree turn, heads straight for the other leg of the chair. And then goes to the third leg and fourth leg and it keeps going in circles like that. So it also makes a lot of noise. So if you can hear that this donk donk and then donk 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 with even intervals, it's like, the robot slave is stuck under the chair again.
Yeah.
And the bumper is a little bit raised from the floor, so sometimes it will get stuck on top of something. It's really, really stupid. It doesn't tell my phone anything because it can't speak with anybody or anything. The only thing it can say is beep when it's full. Let's say somebody implemented this kind of logic inside it where it goes through this very, very small diagram of stuff.
Yeah.
Right? And eventually, you could say you abstracted that to that big circular black thing
with wheels on it,
with a light on it and a speaker, and that's it, right? Nobody's going in there to change anything anymore, and that's the right level of abstraction. It's got an on-off button. That's it.
Yeah.
Right. But it's still a kind of a programmed thing.
You've already said how that's... Oh, have you seen that video game console that came out? It's like this big and it's designed for hobbyists to write games on. Little program. It's like surprisingly expensive for how big it is and how low power it is. I'll have to find the name of that.
So it's like the size of what, the Game Boy thing?
Smaller. Okay. Like smaller than a Game Boy, but it's meant to be very pocket handheld. It's brand new, but it's very retro. It's like just got, I think it might be like monochrome, like just, I don't think it even has a backlight. Like they've gone for, this is a toy for like people to tinker around programming it, not a thing to sell polished. I think you can sell games for it, but that's not really the market, as it were.
No, I haven't actually. We should have a link to that, whatever that is. But what I'm saying is that the abstraction all the way out to our black box with one button on it
is the appropriate
is enough, right? I don't want more insight into its decision. I can deduce what the code underneath looks like. Who knows? Maybe it's actually running a full Linux or something to make those decisions.
It's going to be one of the microcontrollers that you program in assembly, little PIC thing.
Yeah,
it'd be expensive to put anything more.
Probably not even assembly. It's probably written one of those like Verilog or something, whatever.
So yes, true. Yeah, whatever.
So I don't think you can make one rule and say, abstract everything away is bad. You also don't want to go all the way down, right? I wouldn't want to interact with the actual circuitry inside that.
It's for your audience as well, right? Because the person who's writing the software has a customer who doesn't want to know.
That vacuum cleaner is so stupid that it might as well be electromechanic. It didn't even need to be electronic, I think, because like you could literally have little wheels.
Well, here's you
inside.
Describing. I'm sure they exist, programmable to an extent.
Programmer
robot
with vacuum
vacuums.
cleaners. Yeah.
I should look that up. That'd be interesting. Sorry, but it's for an audience who's like got that, you know.
But can it run Doom? That's the question.
Yeah, of course someone's going to try that. Who's got that desire, right? They're like, I would happily buy this thing if I knew that I can improve it, right? Or I can customize it, or
I don't want to do that. I just wanted to clean my floor. I don't want to tinker with it. And so the same thing here, right? I don't want to tinker with the innards of the computer, and I personally don't want to tinker with memory management.
Yeah.
Right? That's, for me, is boring. That's not part of the job I need to do. That's just an internal in the work that I need to get done, but not part of the actual work. And so too for the programming language, has to have the right level of abstraction. But it also has to have a human interface that is approachable. So the node-based or not, or whether you see a linear program like a traditional APL program as node-based or not, you can look at it that way. How should you structure your programs? How big should your functions be before they call each other? I would say you should structure them appropriately. Yeah.
Useful. Yeah.
Yeah, that should be your rule of thumb. Is this appropriate? You ask yourself, is this right?
Lovely non-actionable advice. Yeah.
This code I'm writing now
I love it.
Is going to be maintained by a violent psychopath that knows where I live, right? Yes. But I still want it to look like this.
That violent psychopath is me 3 months from now, and I will act violently on myself when I see what's happened here.
That's a possibility. Unfortunately, it's often actually other people that have to maintain your code. So be nice, right? You want to do it in a level. It's a touchy-feely thing. It really is. You want to express yourself in a way that is clear enough, but not detailed to the point where the overall picture drowns in the detail.
Yeah.
You want an overall level view, but you don't want to make it an impenetrable shell, like the vacuum cleaner. Right? If it needs to be customized, you can't have it in such a way that it's all locked down. You can't get to things, or it takes an unreasonable amount of digging to get to where things are actually happening. Because everything is just abstractions and sub-abstractions at infinitum. So what would an ideal development environment look like? One that knows human nature and like tells you what touchy-feely level you should keep on things?
It's not going to be one thing, is it?
But I might want
to be one shoe, is it?
I might want that to be able to say to my APL environment, say, give me an explodey look of my programs. And
in the conference edition, we're already, there's a chance to go a bit deeper than you can right now.
But that takes you to a lower level, inspecting what's happening at the primitive level, one by one. But I'm talking about the higher level type thing. I have this function. This is my top level function, main, if you want to call it that.
Yes, yeah.
And then, or run.
And then it calls a bunch of other functions.
It calls a bunch of other functions. Now we do have utilities, actually part of the APL language itself, that makes a cross-reference and tells you what are all the identifiers that are being used. And then you can look up which ones of those that are functions and operators that are defined. And then so you can make a whole analysis of the calling structure. But for editing purposes, I might want to bring up all those windows, which I can also fairly easily. Can you write an APL expression that will bring up all the
I'll bring up an editor window for each of the names referenced.
But it might be nice as well to have that.
Is that part of the language? Is that not like a user command or something? It's part of the language that lets you see which names are called by this function.
Yeah.
Like, I understand listing names that are declared within a namespace, but I don't recall.
You want me to show you?
Yes, yeah.
Okay.
What is the thing that lets me, given a function name, I think, is what you're describing, what are the functions that it calls?
Yeah, okay.
And you said language, which obviously is like also contentious. What does that mean? A quad thingy?
It's a quad thing, obviously.
Okay, it's a quad ATX, is it?
No.
It's older than that?
Yeah. No, this is ancient. Okay, so we're going to define a function?
Yeah.
You want to tell me what to type, or?
foo.
This is my main.
It doesn't
function,
need. Yeah, we don't need anything else because it's not going to call. And then
okay, so it's calling boo.
It calls boo and it calls goo.
So we're getting a local variable here called for boo, and then
sure.
maybe we should have a result as well. Let's call
that. We could. In theory, you can just write this as del foo new line boo new line goo new line del. But I guess you're trying to make it slightly more interesting by having things actually happen inside. I was mainly, I assumed we'd do the minimal
like
repro.
Okay.
But okay, we've done a bit more. So we've got a function that returns a result r. It's called foo. It's got one local variable x, which is the result of calling boo, which is a function takes no arguments, just like a script, I guess. A result returning. It could
actually be a global variable as well. You can't really tell.
Anyway, QuadRefs.
Yeah, QuadRefs foo.
And there you go. Oh, and it's not just. So then what, you quad NC on each of those?
Yeah, so then, now we can ask...
If you want to know what the types are.
What are the name class of these?
And you can do right tac, comma... Oh no, quad NC, comma, QuadRefs in a train, and you can get the type and the...
Oh yeah, if you wanted to do that.
Types and the names as a table.
Yeah, just that, right? So now we can see that goo isn't actually defined, boo isn't defined. And foo exists as a function. Okay, but we can
define boo.
Well, we can just do it.
Do it even, doesn't matter. Yeah.
Like that.
And then boom.
Now we have that. Right?
And it's a function. It's
and then
class 3. Cool.
Yeah. And we can define.
Yeah, no, I just literally wanted to know what that was. That was cool. QuadRefs.
And then goo. Let's say goo is a variable like that.
Yep.
So now we can say that
goo is 2.
Goo is 2.
R and X is still 0 because they don't exist.
Yeah. Which means probably they're local.
Yeah. Or they're defined inside, right? If you have a tradfun where the body of the tradfun has a defin definition, presumably it's not going to know that.
No, that's what I'm saying. It's local. I mean, it might assign a local and a global, which we can't really know what it's going to do. But at this point, it doesn't have. If you run it once, it'll be defined, right?
Yeah.
So you run it, and then you can look at that. So then you got a cross reference like this, and then you can fairly easily recurse this and say, okay, anything that's 3 or 4, we look into do a QuadRefs on those as well, right? And then we can build up a whole calling tree.
So but anyway, to get back to what
I wanted to do is I would like to then
explode foo. Into a visual, some kind of diagram or something that's like,
well, let's say
either explorable or it's easier to see at a glance, which is kind of what you're supposed to do.
We do the name classes of each of those, and then we can filter them by that, right? So, what just happened?
You've replicated based on the name class. 0 not equals.
Yeah, sorry.
Yeah, it's alright.
Okay, and now we can edit those, right? Can I do a quad edit on a matrix? Oh, that worked. It actually opened up 3 editors on a different screen here.
There you go. Wow, this thing about dialog APL is, if you can dream it, here it is.
So it opened up these on my other monitor.
Now, of course, this isn't exactly what we're talking about because we haven't got the connections are still based on.
So that's the
text.
part that's missing. It would be nice then if I would have some arrows, right?
Your box that says foo, and it's got now 2 ports. Or 2 little nubbins on the side of the foo box that describe boo and Or I don't know. Actually, no, it doesn't make any.
Well, you could have a little line.
It's an input
that points over here, but it would quickly become a nightmare, right?
Well, that's the other thing is this is not. This function is not amenable to this very much, is it? Because really, you want ones that all take arguments and return results, and then it's easy to know what the little nubbins should be, the outputs of the.
But they might be mutually recursive as well.
So is there good?
It's not necessarily a tree
because the nodes presumably don't do this. Presumably the node-based thing. Actually, we should find out. I mean, that's the other thing. I wanted to mention it because I'd seen it and it looks cool and kind of interesting in this context of like how do you structure a program. Which is, I think we've got loads of videos and talks, and we've talked, in various public fora a lot about solving problems, as in writing even your APL Quest, right, is like solving problems as in here's how to write an expression that solves this specific task that's usually quite data processing-y. But there's a lot, and it turns out it's in part, I guess, because it's so varied, ambiguous, not well defined. It's a touchy-feely thing. Is like, how do I structure my program? How do I make it good and nice to use in the future, nicely expressing what I mean to other people, and so I don't hate myself when I read it 3 months later. That's why I sort of was talking about the Node thing, but I definitely should look into it more to see how does the Node-based programming deal with recursion and maybe like here calling functions where you're not just passing arguments and returning results, but like side effects and things like that. Or are they just sort of hidden under the rug and it's sort of known you shouldn't do that because your diagram won't accurately describe what your thing is? In which case it's not a very good node-based thing, but you know.
So there's this user command that's graphical. So you can see that, so we have these two things that are defined, boo and foo in the namespace. So this is higher level than just on a function, the whole namespace.
So all IDs is just a list of everything that's declared in the currents, in the namespace you gave.
Yeah.
Because you did right bracket xref space octathorpe, the hashtag symbol,
hash,
and then we've
just hash. It's the root namespace.
Oh, yeah, that's right. So yeah.
So it says, okay, this root namespace has two functions, foo and boo.
Yeah.
And then you can see that so this is a function call. Foo calls boo, and it uses the global global name goo and the global r and global x, and boo uses this omega, which I don't remember what this O means exactly, but it doesn't really matter. We can look at the help part, but it's not important.
No.
But the thing is, okay, so I've got these things that can give me a report, a textual report. I can even open up Windows editing these, but maybe a visual thing where I could like adjust the knobs to see how much granularity do I want, how many levels out, giving me a picture of that. Maybe a quick report button that tells me, oh, what are all it's easy for me to see what are all the functions that I call from this function, but I want to make a change in this function's API if you want. Can I do that safely or not? Does anybody rely on the left argument or whatever? And I would like to know what are all the places that call this one. That's something I might want. So I guess that comes for free in the node-based thing, because you just look at what are all the
arrows going to and where they come
into this one, right? Exactly. But I don't have that here, and that might be something that would be nice to have.
Yeah, it's like so that's a question of refactoring, isn't it? And like making it easy and nice. And the compiled language people say, you make your change and then you keep going until the compiler errors stop. You know, that's how they do it. Literally, it's like, or at least the one video, the guy who made the game, it's like a puzzle game. I can't remember, but he has like some programming live streams because he like coded it all by himself. He's one of those guys or something, and he's got strong opinions about programming. But he says, yeah, you just make the change and then you keep on fixing it until the compiler errors stop.
Sounds a little bit dangerous.
And then you know that your code. No, well, you've designed it in such a way using all the type safety and that you know.
Oh, I see.
Works.
Yeah. But in a dynamic language, that might not be the way to go.
No, I mean that's one thing people say.
Or at least then you have to have complete QAs that test everything.
Right, that's what test-driven development is. You make the change and then you keep changing it until your tests pass.
It's dangerous though, because you have to be confident that your tests are complete.
I think all of these have the same. Well, I don't know. It'd be interesting to know. It would be interesting to see if what you could do to find this out more objectively is, at the end of the day, you're having to exercise some discipline. You have to actually put in the effort to make something that works. You know, you can be it's easy, well, very tempting a lot of the time to be nice and lazy and just sort of get the bit that does the case that you're looking at and it sort of works, and then hope that the edge cases never rear their heads.
And if you're a modern tech company, you just ship it. That's it. Let the users
gotta ship it. No, first to market. Early to market is worth about 1,000 times more. Actually, probably the factor's insanely bigger than best thing.
Yeah.
I think it's got to be. Anyway.
We should leave it at that.
I think so, yeah. It's interesting. It's not resolved, and so we don't have any specific advice for you. But I guess that's not what this show's about anyway. It's about just exploring ideas.
I hope you enjoyed listening to it.
Mm-hmm.
So we'll see you next time.
See you next time.